So you will not find some of those system calls in UNICOS. Any feature that you have in COS that's found in UNICOS, there's code that represents what this feature can do. And my attempt here is to just draw the parallels between code that you find in COS and where you find that sort of code in UNICOS. And to begin with, UNICOS is composed of a memory resident binary that's called the kernel. And the kernel is the dark circle represented in the drawing that you see. And this kernel is always memory resident at the beginning of the machine's memory. And within the kernel is composed of 4 basic parts. And we're going to talk about each of these 4 parts very briefly. But the very core of the kernel is the concept of having machine-dependent code. And all the code that's related to the Cray2 or the XMP that's different between the machines is in this machine-dependent directory. And this is typically CAL type of code. And it would represent some of the entry points in exec for interchange and task processing and stuff of that nature. And around this machine-dependent code then, we have the file system, and the file system would relate to the permanent dataset manager in COS. This is what keeps track of the file system entry points, file system structures such as the dataset catalog is in COS. This would be directories and directory blocks in UNICOS. We also have the I/O directory. The I/O directory would relate kind of to the disk queue manager. This is what manages the I/O requests being presented to the peripheral devices. And all these devices are being driven by the iOS cabinet. And the 4th section of the kernel is called the process management directory, or OS directory. And in here are, first of all of your executive requests in UNICOS. These are called system calls. And you have a variety of sys files that contain all the system calls for the system. We also have the scheduling portion of the kernel. In COS, this would kind of relate to the task scheduler, except in UNICOS it's called the swapper. And we also have the cron event, which fires off time events in the same way COS has time events, which is tied to a system call in COS. The rest of the COS internal code is really what are called tasks in COS, and these relate pretty much to the daemons that are found in UNICOS. And the daemons consist of things like this, comparing it to COS, the startup task. In UNICOS, there's a process called init, which represents the startup process. And any site that makes changes to the deadstart parameter file, things like this, you're going to find 2 shell scripts that are processed during system initialization. And these are RC and RC.local. And RC is where all the Unix-specific processes are started, things like error handling and the accounting, things of that nature. And then RC.local is where all of your networking type stuff is set up, whether you've got USCP, whether you've got tape, NQS configuration, all these sorts of site-specific configuration choices. One of the advantages of UNICOS over COS is the fact that many of these daemons can be brought down and brought back up without a system interruption, meaning that the kernel itself does not terminate. And users that don't use that daemon that's being brought down don't see any service change. Whereas in COS, many things require a dead start restart to change configurations in the system. Next, after startup, is the job class manager in COS. The job class manager is really what filters the batch jobs as well as the interactive jobs through the system in COS and controls the number of jobs that can run at a time and this sort of thing, and sorts them depending upon the types of resources that they need. Job class manager typically keys off the job card. In UNICOS, this is known as the network queuing system. And the network queuing system has a variety of daemons. One of the first daemons is NQS daemon, and that keeps control of these batch queues and is the basic job submitter. A second daemon is net daemon. NQS does have the capability of submitting jobs over the network. For example, you could have queues named that send a job to a different machine based upon the queue name. And NetDaemon uses TCP to communicate to NQS on other machines. We also have the log daemon, and the log daemon keeps track of what the NQS subsystem is doing and keeps track of for debugging and job submission records. I'll also point out that in UNICOS 5.0, the network queuing system keeps its own accounting records on each job, separate from the process accounting records that are standard Unix. The next task to talk about in UNICOS, or in COS, is the System Performance Monitor. In UNICOS, this is known as System Activity Data Collection. There are two applications, SADC and CRAPERF, that read counters that are maintained in the kernel. Obviously, there's no comparison between some of the statistics meanings because they're different operating systems. For example, file system statistics and inode gets and things like that. SADC is fired off every 10 minutes and is controlled by cron to determine how often you want to gather system statistics. And it can keep both a binary record and a text record that can be looked at later in the week. There's also a utility called SAR, which the users have capability of using, that gathers information from these same counters in the same way as SADC. CRAPERF, however, is more of an interactive operator tool. It has graphic windows that display the various statistics in a graphic mode, but keeps no log or trace of the statistics that are going past the screen. Once they're off the screen, they're gone. But with CRAPERF, you can look at memory maps and see how the memory is being broken down, and also determine how many jobs are on the queue, how much swapping is occurring, system buffer I/O. Those sorts of things are much more visible in an interactive environment. And CRAPERF requires X windows on the front end in order to run. The next task we have in COS is the message error processor, MEP, and this keeps track of iOS and executive memory error message packets. And in UNICOS, this is known as the error daemon. The error daemon is fired up by the RC script on initialization and keeps all these memory error packages and iOS packages in a file that's in the directory /usr/adm. And you have a couple utilities like errorpt and olhpa that look through this error file. The next task is in COS, a tough one to compare to UNICOS, but the message task is what routes messages from all parts of the system in COS and manages a system log. This is one of the features that COS sites use in a variety of different ways, billing as well as tracking jobs that have run on the system and users say that they didn't work correctly. Users have or administrators have a tool called extract that goes through the system log and looks for job information such as $log records and things of this nature, job termination records. Well, in UNICOS, we first of all have a message router called the syslog daemon. Syslog-D is ported from the Berkeley environment and is a text message system log controller. And you have to write your applications to actually use this log. Very few UNICOS utilities presently use it. But if a site wanted to, they could write into their compiler. Anytime the compiler hits a certain error message, it could go off into the system log. Every time a user gets a particular error problem, it can go off to the system log, and the administrator can track these sorts of problems. If a site really wanted to maintain a $log concept, they would have to modify the shell and force a set-v flag to the shell, and then also have the shell keep a copy of this in the system log daemon in the syslog directories with some sort of timestamp that's included with them. However, in UNICOS, the new 5.0 daemon accounting system keeps a lot more detailed accounting information, such as job numbers associated with processes and job termination records. And there is a new utility. There's a variety of accounting logs that are maintained in the directory /USR/ADM/ACCT/DAY/ and then whatever type of accounting records they are, such as process accounting, tape accounting, USCP accounting, NQS accounting, these sorts of accounting logs. And there's a variety of utilities that manage this set of records, such as CSA Run, which generates your daily accounting reports. And if an administrator did want to track a job, he could use a CSA JREP command, which would generate job reports by job numbers or user IDs or a variety of attributes of this nature. However, this type of report would not contain exit numbers and things. The other option is that the site can keep a track of the JA utility. The JA utility does keep exit statuses and this sort of data. And if the site set it up, they could set it up so that it's not removing the .jacct files that are in the directory that the job's running in, and save those off. And then use JA later to go through all these sorts of things and get some sort of accounting or some sort of diagnostic tool to track jobs that ran on the day before. But those are a variety of different options to keep track of the different types of system log statistics that are maintained in COS, and a variety of tools to read them. The next task to talk about is the flush volatile device. In COS, this is what backs up the SSD and buffer memory volatile file systems. Well, in UNICOS, there's 3 different ways of configuring the SSD or buffer memory. The first one is what's commonly called LD cache, logical device cache. And this is probably the most popular way of using the SSD, but it's often shared with the other 2 capabilities. With buffering, system buffering put in LD cache, there's an LD sync command that causes those buffers to be flushed to disk. And this is what actually flushes and backs up the volatile device data. This in 5.0 is actually being put in the shutdown script and would also be something that could be fired off by cron. The second configuration of the SSD and buffer memory is known as secondary dataset segments, SDS. This portion of the SSD is gotten to with the assign command, saying that you're going to want so much space in the SSD for a Fortran unit. The only time that this data is backed up is with the checkpoint feature. Every time the job is checkpointed and rolled off to disk, the SSD portion of the job is also saved off. So the checkpoint feature would determine what your at-risk time is in terms of backup of that portion of the SSD. And the third configuration of the SSD is as a file system. And as a file system, you simply have to copy it out of that directory into some other place where you'd store it on your disk subsystem. And it's very often that they put the copy in the shutdown script, along with some of the other features such as LD sync and checkpoint. The operator can also execute any of these commands at any time running, such as the sweep command is in COS. The next task to talk about in COS is the tape queue manager. And the tape queue manager in UNICOS is a daemon. It's not memory resident. Now, some of these daemons can be locked into memory. There is an administrative feature that says lock this particular daemon in memory. TQM is related to 2 daemons in UNICOS. The TP daemon, which maintains the tape protocol to the iOS. And this is a daemon that's sending D packets and C packets to the iOS to manipulate tape and handling that protocol. The second daemon is the MSG daemon, and the message daemon is the operator interface. This is what's keeping track of the tape mounts that are occurring and the various things that are going on with the system, such as file system monitoring and other things that can be going on with the system. The next tasks to talk about in UNICOS are SCP and STG. These are the station call processor. UNICOS does support SCP protocol, and the daemon that does that is called USCP. USCPD is the daemon that handles that actual protocol with the front ends and manages link control packets and the segment buffers. It also has a script called USCP init that starts up the daemon, and the actual staging portion of the fetches and disposes, such as STG does in COS, is a USCP CMD daemon that controls the fetch and dispose dataset transfer. And with 5.0, you now have a new command called USCP ops that allows an operator interface into USCP to control job queues and things of that nature, as seen by USCP and UNICOS. The next task to talk about is the Superlink project. Superlink is a task in COS. In UNICOS, it's actually buried in the file system, known as something FSS or file system switch. In a datasets or in a files inode structure, there's a flag that says whether the dataset is online or offline. And dependent upon those flags, the file system switch will take it to the appropriate driver code to bring the dataset into the system. One other thing to bring out is that the permanent dataset manager has a lot more features in COS than what I've talked about in terms of file system management. And two of those that I want to bring out are security and archiving. In UNICOS, these are separated features. UNICOS 5.0 has a security feature implementation that does allow tracking of data sets, logins, etc. And that security feature is spread out throughout the system. Some of it is within FS, and some of it is within some SP commands, such as, SPACL is what maintains an access control list to get to a data set. There's also a security log daemon and a command called reduce. And reduce can process the security log and keep track of these data sets that are being accessed and stuff. You also can set a user trap flag that allows every keystroke a user types in to be logged in the security log. The second portion of PDM to bring out is the archiving system. In UNICOS, this is known as data management or data migration. Offline dataset residency is the only support that we give in UNICOS. For actual system backups, this is a separate feature, a standard Berkeley command called dump and restore. UNICOS 5.0 does support data migration. The file system will determine that there's running out of space and will start offloading data sets to a front end or as supported to a tape. A site would have to modify it to offload it to a front end tape, CFS, these sorts of medias. The entire archiving system is under /USR/DM. And all the commands, there's probably about 25 commands related to the archiving or data migration project in this DM directory. And many of these maintain tape volume catalogs, some maintain the online data set catalogs, things of this nature. The last piece of a COS code is really dealing with EXP and CSP. CSP is the control statement processor that actually does the cracking of the JCL and determines very specifically what the JCL interface looks like. In UNICOS, this would relate to the shell, and it's actually running as a user process in the same way as CSP does. And there are two shells supported, the Bourne Shell and the C shell. The second portion of this user interface is EXP. Now, EXP does a couple of things. It first of all creates the job when it comes into the system. It interfaces all system calls to exec and protects exec from improper system calls. And it also terminates the job. Well, in UNICOS, there are two commands that deal with job initiation and job termination, and these are getty and login. And these would relate to part of the EXP interface. However, the rest of the EXP interface is really buried in the kernel itself. And this is one of the advantages of the UNICOS kernel environment. If we were to compare what the interface looks like to do I/O between COS and UNICOS. In COS, we'd have to start off with the user, and he'd make some sort of I/O request, and he'd have to exchange out. So we'd go to exec. Exec would then go to EXP, because EXP has to protect the system from the user and make sure he's doing everything right. So EXP will then make an exchange into exec. And exec will then pass it off onto the permanent data set manager. And there may be other things that run in the meantime. PDM then will manage where the data set's going to go to in the file system and make an exchange back to exec, in actuality to schedule the next piece of code called the disk queue manager. And the disk queue manager is what's going to handle the actual I/O request. DQM will then figure out he wants to start I/O, so he's going to build a packet and send it off to exec. And then exec can then send the packet off to the iOS. And this is what it takes to get an I/O initiation in COS. We've got 1, 2, 3, 4, 5, 6, 7 exchanges to initiate I/O, just to get through the thread of getting I/O initiated. Well, in UNICOS, you just go user straight into the kernel. You're in the kernel for the system calls, and you can just initiate I/O. One exchange. So in comparing threads of doing some of the common things that you have to do in COS, you have a lot less exchanges and a lot more productive work being done. So that's about it. Now, I mentioned all these system processes. You can do a PS. This way you would get this type of report. A PS command says all the processes that are running. -E says everything, F says full report. A pipe is a way of connecting the output standard out of one utility to the input of the next utility, kind of like a local data set. And I'm going to pipe this output into a grep command, and grep does a pattern search. It looks for a certain pattern, and the pattern I'm going to look for is root. And this will tell me all the processes that are related or have root on the command line or on the line. And these are the processes that we just talked about. We have swapper, the initialization process. We have an idle loop for each CPU. We have the root login. There are some 5.0 stuff in here for the share daemon, the security log daemon, hardware error daemon, tape daemon, message daemon for tapes, some NFS daemon, amount daemon, etc. Or NQS daemons, USCP daemons, all those sorts of things. This was just grabbed off of a system a couple of months ago. So this will tell you an idea of the system processes that are running outside of control of the kernel. And these are going to be site-specific, tuned to the way the site is set up. This isn't all of them or necessarily any list. If you wanted to look up what any of these do, it's in the, what is it, SR 2022 manual, Administrator Commands. That's where all your daemon processes will be documented. UNICOS 5.0 now has compatibility with the COS resource data management capability in COS, and there's a lot of similarities between them. In UNICOS, or in COS, you now have an RD data set, a resource data set that contains attributes for each user that's logged into the system. And this replaces $account and $validation when you enable resource data management. In UNICOS, this is called the user database, UDB. And it kind of replaces or works alongside the standard Unix tools, password and group. These files are what a standard Unix system uses to administrate users. To add users, you'd have a password for them, password entry, and you'd also say what group they're in. With 5.0, there's a new command called UDBGen. And UDBGen is what the administrator is going to use to set up users, to determine what their time limits are, their memory resources are, disk space is. all these sorts of things, what their security compartments, security levels are, a variety of things that are user-specific information the system uses. And there's also a public version. This is a private version that's UDB because it's got lots of information in it. There is a public version available. Now the system maintains all this stuff and uses it, and we have two commands. I mentioned UDB Jan. There's also UDBC, which would relate to RDEdit in COS. It's an interactive editor to generate these entry points. And UDB in UNICOS, the numbers after the command specify what manual it's in. And the 4 manual is the file formats manual. A 1 is the user commands, a 2 is system calls, a 3 is libraries, and a 4 is the file formats. And this is specified elsewhere in your documentation. So if you have people that are going to be maintaining and setting up these users, they're going to want to look at the UDB man page to look at the fields that they can set up. And that tells you everything about what you can assign to a particular user. In 3.0, it was all in uentry. And those that set up and learned 3.0 with uentry, it's all obsolete in 4.0 and is gone. It's all called UDB, User Database. And you have the capability of specifying different limits for interactive and batch. The next page kind of shows what the command looks like. It should be UDBC instead of UDBVed. That was an old name. And this is in 5.0. So this pops up on the screen, and the operator, whoever, can set up all the fields. UDBGen will also take a standard password file and expand it with a bunch of empty fields. So you can start with a bunch of empty fields from your password file and upgrade with UDBGen. It takes a couple of different types of entry, input data sets. And again, the 2015 is that file formats manual. But this is all 5.0, so you have to have a 5.0 manual to look at a UDB man page. There is, however, information in your anthology on those man pages. You do have copies of that in your anthology. One of the new things in UNICOS 5.0 is called the Fair Share Scheduler. This was based upon code that came out of the University of Sydney in Australia. There's a design paper from the original writers of this code in your anthology, and it allows a resource allocation tracking system for users and a way of balancing users into the system. It's designed to be as fair and understandable and predictable as possible. One of the things that's different between COS and UNICOS is that in COS, it's a variable time slice that the user gets, depending upon the scheduling algorithm. In UNICOS, he gets the same time slice. Everybody gets the same time slice. It was how many time slices they get that makes the difference. And the Fair Share Scheduler tracks a user's accumulation of usage and then has weighting factors to determine whether he can get in or somebody else gets into the system. Resources are specified as shares and modified by some sort of usage history that's kept in the user database. The user database is where this is all set up. There's also a command I might point out called scheddev that is an administrator command to balance between batch and interactive processing, and is one that's typically fired up in the startup process from rc.local. And actually came out of work from Berkeley where they had to balance batch loads and interactive loads. That's a tough thing to do in an environment, to give the interactive people the response they want, but get the batch job throughput. There's a little bit here about job process recovery. I haven't really studied up on 5.0 and all the specifics of it, but these were some of our objectives. If it was a multitask process that was going to lead to incorrect results, we had to have some way of stopping the recovery of it. A checkpoint must ensure that a good chance of restart is going to happen, or why checkpoint? If it's not a recoverable situation, there's no sense in trying to checkpoint it. One of the things that a site has to make a decision on, especially going into future architectures, is trade-off between at-risk time between checkpoints and the performance overhead of checkpointing a machine that has a huge memory. If you look at an XMP to cray disk ratio, it's rather high. But if you start looking at amount of memory to cray disk on a cray 2, cray 3, etc., how much time are you willing to spend making sure everybody's checkpointing? The kind of jobs that you'd probably want to checkpoint are the ones that run for 10 hours, 15 hours, day after day, and the ones you don't want to checkpoint are interactive users and interactive applications. So a site has really got to come up with a policy that makes sense for their site, in particular for their machine size to disk ratio. The Cray 2 people have been fighting checkpointing for a long time because of the overhead of dumping 256 meg of memory off to disk somewhere and making sure that the jobs recover. I was at a site recently where they have a Gauss 82 that runs in the background and runs for months. The guy runs at a very low priority and just chews away the idle time, away from everybody else and doesn't pay much for it. But you don't want that thing to be 3 months into computation and, bomb out and not be recoverable. So recovery is a definite needed thing in a supercomputer environment. You just have to balance the performance issues with the at-risk time that you're willing to take. One thing that's different is that recoverability must not depend upon swap activity. In COS, recoverability and swapping between memory and disk are one and the same. In UNICOS, the swapping activity does not have enough information to recover the job. And we don't want that overhead either. There's more overhead on the COS counterpart of job recoverability. So in UNICOS, we did not touch the Unix swapping mechanism. That is intact. And it still has the same low overhead that is associated with that. We added an add-on interface of system calls that is automatically fired by timed events to do the checkpointing for us. And it's all being done within the kernel. So recoverability and swapping are two different things in UNICOS. This also means two different places in the file system where they go. You're going to have a /drop file system, and you're going to have a place where swapping is going to occur. And you're basically almost doubling up on file space usage. Nobody else can use those file spaces either. We'll talk about file system in a little bit. The rest of these, I'm really just, you've probably browsed through them already. Recoverability, we want transparent to the application. There are applications that force recoverability within the application. You may want to reevaluate that depending upon your site policy on this. Accounting statistics must be accurate, resource consumption must be accurate, that sort of thing. Again, NQS is what, when he fires off an NQS job, is going to control the checkpointing of that job, and that's really where we want checkpointing to occur, and it's all under NQS control. The SSD in UNICOS can be used in 3 different ways. It was first identified that we could use it as a file system, and we just configured it as part of the file system, such as /SSD, or we put /temp and /bin and /lib on the SSD, those sorts of things. Logically identical to the disks, they gave us transfer rates of 20 gigabits per second, and frequently used partitions were like /bin, /lib, /drop to give you your checkpointing faster, and /temp. Also, we can use it as a logical device cache, and this is a UNICOS 4.0 feature. It is transparent to the application. Basically, the administrator configures to each partition of the file system a certain number of buffers on the SSD. It's dynamically allocated to each particular file system. The UNICOS file system is broken up into sub-file systems, and each sub-file system can't overflow into the other ones. Some people consider that a disadvantage over COS. Other people consider that an advantage over UNICOS or over COS. It depends upon what you're trying to do with your file system. Generally, it's a disadvantage when your application runs out of file space, And it's an advantage when the rest of the file space isn't yours and you're not supposed to use it. So sites that want to restrict file system usage uses that. In fact, in COS 117, there's something called disk map with the resource manager that allows the administrator to set up what amount of file space the user can use and where it is in the file system. It sets up a bitmap of where this particular user is allowed to use the file system. And this would relate to the way you configure the file system in UNICOS, all the different groups or sub-file systems that you set up. So each file system can be configured with a logical device cache. You're going to put /bin there, /lib, /temp, those sorts of things. But then you can also assign a certain number of buffers to each particular user's file system too. And it really depends upon how you set up your file system. And that's one of the tough things that a site has to go through. Most sites go through 6, 7 file system configurations before they get one to where they've got it. And you're going to see several changes when you go through that process. A lot of it's still on trial and error basis, but I'll talk about ways of predicting what that file system should look like in advance. So with this, you can then dedicate a particular amount of the SSD to a particular user or group of users based upon the file system they're in. Each one has a number of buffers and length of the buffer. So file system /bin gets 50 buffers, each one 512 words, something like that. Allows tuning to specific I/O requirements. We have an LD cache command that tells us how our hit rate looks. Typically, they're up in the 90 percentiles, 95 to 99 percentile hit rate, where we find it on the SSD rather than having to stage it from disk. And we can tune it with the LD cache command. The I/O rates, however, are the same as in the SSD file system as typical transfer rates. The third method of configuring the SSD is as a secondary dataset segment, SDS. And this is gotten to by the assign command. So you can assign SDS, Fort.1, for example. Assign the Fortran Unit 1 to the SDS structure. And we'll look at a job example like that later. This then allocates, this is a dynamic memory on the SSD that's scheduled in the same way as system buffers are on the mainframe, allocated like main memory. It's released by the system when the process terminates. So when you're done with it, it's gone, it's not yours. Whereas in the file system, as long as your file sits there, it's your space. And with LD cache, as long as your hit rate's 99%, you're sitting in the same buffer, unless somebody has to get something that's not in the cache and has to go to disk. BA and LA are maintained per process, so each process has a BA and LA set up for it. There's something called a hot path in the kernel, which allows direct transfer to the SSD, and they predict a 10-fold increase in performance using the SDS dataset segment. And there are system calls to get to the SDS dataset segment as well. And this is occurring with a backdoor SSD. I don't know if the side door SSD will get the same performance. The next page has a sample of a LD cache command and shows most of ours are in 91 isn't so good on a drop file system, but 99, 98's a couple that could be worth looking at in the 80s and so forth. And then this says the size, the number of units, reads, writes, hits, misses, and then your hit rate. So the administrator can use this to see how he's doing with his SSD utilization. But now this is where the administrator has control of using the SSD to the particular file systems and gives the whole system a better usage of the SSD. Other sites want to give the SSD to the people that pay for it, and that's where SDS is more useful.
Question
Yeah.
on this thing here. So if a user has access to the SSD and say assigns a particular file to that device, he then has it for the duration of that task.
There are some commands that he's going to be able to control the allocation and release of that, but it's for the duration of the job.
So there's no mechanism similar to the oversubscription process?
I have to look into hold, no hold capabilities and stuff. I have to look into that in more detail. That was a hotspot that was being discussed on how compatible that is to COS. And the answer in the past has been, you're going to have to learn to use the SSD a little bit differently than you did in COS. They say there's something on SSD oversubscription that is in 5.0, but I haven't seen specifically what they're doing there. Part of it may be the fact that the share manager and the NQS are doing some things to allow jobs to initiate, even though SSD isn't available yet, and that sort of thing. But I haven't looked into that in detail.
I guess the problem is that if you've got a job that's running 4 or 5 hours and it grabs a hold of a portion of SSD, it's never going to get it back until that guy
Right.
other users locked in.
Right. And that's where LD cache may give the better performance for a site. That's what the recommendation has been. Don't try to, perpetuate those COS thinking into UNICOS in some cases. And it's something that you simply have to evaluate on site with your migration group or whoever's administrating and making decisions on the system. But a lot of people brag on the LD cache over thinking of the way you did in COS in terms of oversubscription and getting total utilization out of the SSD. But other sites are driven by money, and they charge for the SSD, and it's easier to charge with an SDS usage than it is LD cache. So these are some of the things you have to think about. But there is a little bit about oversubscription on the top of 221, and I really haven't looked into what they mean in terms of 5.0 support.
Getting back to LD cache, in order to optimize the hit ratio, it seems that it's all dependent on your being able to predict what the next block or whatever.
Yeah, have enough SSD to freely distribute among your file systems and stuff.
If it's doing sequential I/O, that's not a problem.
Uh-huh.
If they're doing direct access I/O, that could be a serious problem.
Yeah.
Are there any mechanisms where the user can guide the choice of the next blocks to pull in?
Not that I'm aware of. I'm not sure what the question is.
Well, I guess when the algorithm that the system's going to use to decide what to buffer in from, if the guy's doing reads and it's going out there to get more than what the user asked for in anticipation of future reads.
Uh-huh.
Right now, the user doesn't have any control of that. It gets what it gets.
Mm-hmm.
If the guy's skipping around all over his file, then that may do him no good at all to have.
Yeah. When you get into this case, you really have to see what they're doing and find the best way to use it. I'm not sure I can answer that any better than that right now. Why don't we take our lunch break? If anybody needs help finding places to eat, there are maps up front, stuff like that. And we'll come back at 1 o'clock and pick up with this. And if you have questions in the meantime, feel free to ask them. First of all, were there any questions from this morning? We've got some I/O issues, I/O questions. I'm going to get together an I/O optimization. There are 2 packets in UNICOS I/O from the Fortran people, and I'll get those to you to talk about some optimization techniques and stuff like that. So those will resolve later in the week. We left off on page 224, talking about security. Again, I don't mind if you use your keyboards while I'm talking. One of the new features that has been added into the Unix-based operating system UNICOS was security. And the Department of Defense has what they call the Orange Book that has classifications of security with various features or attributes of the systems to determine what classification it goes into. And certain operating systems are certified at certain levels. The only one I know of, I think, is Multex is certified as like an A1 verified design system. But basically speaking, in terms of security features, A1 is the most secure, and its differences between that and the B3 is formal documentation and testing and that sort of stamp of certification that goes with the security feature. Basic Unix, we assume, and this isn't certified or anything like that, but Unix is somewhere about a C1, and it has no audit trails of data set usage, a variety of things that are required by higher systems. COS, we do feel, somehow fits in between a C1 and a C2. Again, these are not certified, that's what I'm trying to say, but we do have accountability, we have the capability of user discretion with commands like permit. We have audit trails that are kept with the data set, tracking access, these sorts of things. Puts it above a Unix security. Read, write, maintenance, permission, control words, things like that. Now, UNICOS has added this security feature with a set of commands that in UNICOS 5.0 begin with the SP prefix. There used to be a command called ACL, but in 5.0 it's going to be called SPACL along with all the other commands. And this is what the user typically uses to specify an access control list of who can get to his data sets. And we're going to talk at the user level about security later. We're going to come back to it. But we do feel that Unix, we're basically in the process of an outside consultant looking at it and making actual changes to code to somewhere put it in between a B2 and B3 system, and then we're going to determine what level to certify it as and go through the certification process, supposedly starting the certification this year. So right now, an outside consultant has been looking at it and making specified recommendations for some improvements in certain areas. But it was originally advertised somewhere at a B3, but this past year it's been talked about at more of a B2 level. And trusted facility management is really the big difference between these two, and the proven resistance to penetration. These are the highlights. I've been asked the question about that recent virus that infiltrated all the Unix systems all over. I had a class at General Dynamics the Monday after that incident. And that particular virus, what it did was go in and use resources. It just hogged memory and these sorts of things. And with UNICOS 5.0, the resource management facilities would have protected the system from that sort of thing, depending upon how many resources that particular process was assigned. So it couldn't have gone in and used up all the memory in the way that it did on a standard Unix system. But that virus was into standard Unix, and there were UNICOS systems taken off the network just to protect the systems, just in case. But I know of no system that got penetrated by it. So maybe that's a test case for us on the resistance to penetration. We're going to look at both the user and the administrative side of this a little bit later. Another new feature with UNICOS 5.0 is what's called disk space management. And all these commands begin with the prefix DM. Of particular interest to the user is DM get, which is what gets his files off of an offline database. But one of the features, and this is basically an equivalency issue with COS, one of the features of COS is to be able to manage your file system so that when it starts to fill up, you can offload things and generate hit lists depending upon age of data sets and things of that nature. And UNICOS 5.0 does provide all of this. I'm looking at both 5.0 and 1.17 right now, and they look like they pretty much match up in capabilities and stuff. They both have error recovery, database validation checks, things of this nature. I'll talk a little bit later about all the commands on the user and administrative level. One of the holes, though, I think that does exist in archiving right now is that if the data set is offline, when you open the data set, you just hang there. There's no message put to your console to say that you're waiting for an offline load. There's no sort of message while you're waiting like you have in COS. And that can, tend to frustrate a user whenever a file's being opened up and it happens to be offline, waiting for an operator to mount this tape, and he's not even notified of what's going on. So that's one hole, I think, that exists right now in comparing the two systems. Also, with the get COS command, you're going to be able to read COS archiving data sets and pull those apart. And it works in conjunction with COS read to split apart the PDS format of the archiving tapes. Get COS pulls the catalog off the tape, and then you can pull the PDS file and pull out the particular archive data sets that you want.
Will this exist on 5.0?
Which? I think they're basically still a migration tool. Companies moving this stuff back into standard software development, and I think it may be worked into standard releases, but with 5.0 cutoff and everything, I don't think these are actually included.
But they are available.
They're available, and I'll be able to provide you with source to them, except I do not have source for DM or get COS right now. It's a tool that was written by BRL out in the eastern region, and the analysts there wrote it. And I'm, for example, not even positive that it's what Cray is going to go with, but simply one of the tools that's out there that we can provide right now.
And that's particularly attractive at our sites as we have a lot
Right.
of
Yeah. One thing I haven't mentioned is that there is a new migration coordinator in the company, and his name is Joe Whittle. And he's got his migration meeting tomorrow, but Wednesday or something like that, I'll have him come in and talk about what he's doing, and this is one of the areas that he's going to be involved in, is whether that tool will be released that way. Yeah. I'll let you know about him later in the week. But I have COS read, and I know get COS is somewhere in Mendota Heights from what I've heard, but I'll have to check on that. One of the big things that's different between disk management in UNICOS and archiving in COS is that the backup capabilities are not the same. Disk management was never meant to back up the entire system. There are utilities dump and restore. Users can use tar, things of this nature to provide backups. But they do not double as they do in COS. And COS archiving also doubles as the system backup control. And I suppose if you really wanted to, you could squeak the archiving or the disk management system into providing that capability by making sure it archives everything. But I'm not sure about what overhead payoffs or type of loading you'll have performance loss because of that going on. I don't think anyone's ever tried it. Doing wildcard DM puts. The command to actually force it to migrate is DM put. And those are the two that are in the user guide. DM get will retrieve it, restore it, and DM put migrates it. Presently, the appendices in your workbook don't have the marked changes, but I'll try to get them to you by the end of the week for these archiving and resource management commands. In COS, the archiving required new catalog structures. They split the dataset catalog into a backup catalog and a master catalog and DXTs that were previously in the dataset catalog. In UNICOS, they use the existing structure and is basically what they call a handle in the inode. And then the file system on the open determines that this is an offline dataset by this flag set in the inode, and then goes off into the data migration software to let the daemons know about it and interface to the kernel. There are system calls to this archiving feature. And I haven't looked at library capabilities between the COS archiving library calls and the UNICOS system calls. So you could probably come up with some sort of comparison on what to do in those areas, but I haven't gone through that process yet. In COS, the archiving automatically recalls the archives. In UNICOS, you'll be able to allow selection of automatic retrieval, and if nothing else, the DM get command will kick the archiving system or data management system into restoring the data set. In COS, it's archiving is primarily to mainframe or to iOS online tape drives. UNICOS 5.0 is released with tape, but you could write your own what's called a media-specific process to dispose it off to front ends or to send it to CFS or whatever archiving media you want. But the feature supports only online tape right now. 6.0, I think there will be additional media-specific processes, they're called MSPs. Right now, the one that we support is called DMTP MSP1. And if you want multiple copies, you fire off two of these, TSP1 and MSP2 for multiple copies of your offline data sets. One to CFS, one to a front end, something like that. There are a variety of ways also to trigger the data management system. There's a facility called File System Monitor, which can kick the archiving system in. Or there's the data management system itself. The disk management system has this file descriptor control table, and the system will watch itself and kick in archiving if you hit thresholds of getting too full and stuff. And we'll talk about those types of commands later. COS archiving has a fast recovery after a disk failure. This is part of the backup capability that it provides. In UNICOS, you're not going to use this migration database for restoring the system, but go back to your dump and restore tapes to restore the system back to online. And UNICOS archiving allows the omission of particular files and IDs, saying these are not candidates for offline residency. And in UNICOS, you have the same sort of thing. It's called a .keep file, and a user can put a .keep file in his directory and say, don't look at these right now. Though they could be forced off in priority eventually, but I haven't looked into that specifically. So application that opens a file that's offline or a command that's invoked that's offline, when the open occurs, the system will kick in this archiving system to bring the tape daemon to read it back online, that sort of thing. And dmget and dmput are what move it back and forth. I've got some flowcharts and stuff I'll be adding later tomorrow. Message types. In COS, there's what's called the system log. And everything is in one big data set called the system log. And extract is the tool that reads that thing. In UNICOS, there are 7 message types, and in UNICOS we have support for most of these to some extent. The first message type that we have in COS is what's the ASCII string messages, the stuff that's in $log typically. And this is typically used by a user support staff or administrator to find a job that was run previously and to find out what went wrong if a user has a complaint, or to backtrack the history of a particular job run. In UNICOS, we have very little support for this. There are basically 2 things that are the closest thing to this type of information. First of all, when you invoke NQS jobs, there's a set -v or X flag. The X flag echoes just the command line without the shell parsing and stuff. For example, a.out with an IO redirection of in. With the X, the only thing you're going to get is the a.out. With the V, you get the whole line. So I used to, and this was just picked up from habit from somebody else, used to tell everyone to use the set-X flag. And then this tells the shell to echo what it's processing. But with the IO redirection, meta characters, things that are interpreted by the shell, not everything is output back with the X flag. So the V flag is what I recommend now. And you'd probably want to recommend your users to do that as well. We'll take a look at this output and what it looks like a little bit later. Now that isn't kept anywhere. That's just returned back to the user. So this site that wants to track that could route it through the system log daemon or something like that and keep it on a log on front ends or anywhere, but is presently not a hook in the system. It would not be that difficult to do, though, because if you know syslog how it works in the library calls. You'd go to the particular applications you want to log things, and this would probably be the shell. So you'd have the shell generate these messages. The other capabilities with the JA command and account com. Now when a job runs, he leaves two records. And in 5.0 there's a third record, but nobody reads it yet. But there's a process accounting file, the PACCT file. And then there's a .j account file in the user's running directory. And when the job runs, he's got his own accounting record, which is duplicate to the system process accounting record. And the third one is when the job terminates. In 5.0, there's a job termination record that's also being kept. Now, JA is basically charges on COS. That's what it looks like in output and everything, the last thing in $log. By default, though, those records or those files are removed. Those .j account files are removed by default. So the site would have to configure it if they want to keep those things around, and then consider the space management issue of how much space those things can take up. And you can fire them off by process as well as by job. So if you're multitasking, things like that. AccountCom is the standard Unix utility to read PACCT. JA reads that .jacct in the user's running directory. And then AccountCom reads the system PACCT file. Second type of messages is the station messages, station commands and stuff. There's some support with USCP ops in 5.0, though I don't think you keep track of all your station commands. I haven't looked at what type of output that log is, but there is a log maintained there. It's pretty hard to make comparison between statistics kept in COS and statistics kept in UNICOS. But you have system call counts and inode reads and transfer rates and all sorts of things. So I don't want to get into the specifics of that area. One of the best tools to read that stuff, though, to really see what's going on with your system at that particular time is CRE-perf. And I'll show you a display of it later. But I can really show you the details of the various counters that the kernel's keeping. And then these utilities, SA1 and SA2, one fires off a text report, and the other one fires off a binary report that you could then write a tool to analyze on your own and get system utilization information and that sort of thing. And we can come back into that later in the week if you're interested in it. Finally, we're task debug messages like from TQM and SCP and stuff. And in UNICOS, the daemons do maintain their own traces, and the location varies from daemon to daemon. I haven't listed them, but the man pages have utilities to read these traces and stuff. If you're familiar with COS, there's a TDI command, a tape dump interpreter and stuff like that. In UNICOS, these are already formatted things that you can just go in and analyze, traces that have been left by the daemons and stuff. And they're switchable on and off depending upon whether you want them running. The next page shows what a typical 4.0 report looked like. And this is a standard Unix report, really, showing the account name, the login, and the time, number of connects, disk blocks that were transferred, and samples, and system billing units that can be configured for the system. The system billing units do not match up to COS SBUs either. It's pretty hard to compare some of those statistics. It's like apples and oranges. That's a daily report. I think this one's, this one is a daily report. Run account fires up at 4 in the morning and generates this and some other cumulative sessions and stuff like that. Now this is 4.0, and I really don't have specifics on 5.0 reports yet. So
this is presumably generating this account, this report from records written by some of these.
PACCT. Every time a process terminates, its process statistics are written into PACCT, and that's what these are reading in 4.0. Now in 5.0, I haven't got the specifics and what commands read what yet, but the daemon records aren't kept track of yet, just the process accounting records. In fact, in the man pages, they decided not to document the daemon accounting records because they didn't want them cast in stone. because they wanted options to change them for 6.0, which I myself didn't agree with. Were there any other questions? Anyone that wants to get into accounting specifically, we're going to get back into it and get into specifics as you want. The operator interface. UNICOS does not depend upon the station for the operator interface. And in COS, all operator interfaces through the station. So in COS, everything goes through SCP. In UNICOS, nothing goes through USCP. However, there are hooks there so that operators on front ends with stations can do some operational stuff, but not everything is supported. The basic operator interface as presented in UNICOS is really this operator display, which is a refresh display the operator can use to poke around with the system with the screen being refreshed. And the first thing it offers is the tape mount messages and interface between the user and the operator. And there are library calls to allow you to write messages to the operator, command level commands to send a message to the operator through this interface. So the operator will type an OPER up, and then he's got the screen that he can change the refresh rate on it and provide information-only messages, and then the messages that require action. And the action is a reply the same way it is in COS. So that's what the operator will bring up. And we have a tape mount up on the lowercase showing us the mount volume, the device is going on, who it's for, in this case the operator, and you can reply or cancel the device name. So the other commands would be like PS and stuff, and this is all independent of the USCP interface. One of the new things in the new direction that the whole the company's going into is much more interactive and X windows. We have a picture of Cray Perf on the next page, 234. And with our future machines, we're going to have this new operator workstation out, which is Ethernet connected into the system. And in fact, all your iOS consoles will be gone. Your kernel displays will be Windows on operator workstation. This is for future machines that are coming out. This particular example has a whole bunch of displays that were brought up by Cray Perf and then dumped off. This was a Sun running X Windows and dumped off with a screen dump command and then PS Sun script to write this to the laser printer. And we have, well, let's see, 1, 2, 3, 4, 5 windows opened, or actually 6, 7 windows opened by Cray Perf, and then there's a window open for the session itself. And we don't see what was actually typed in to bring this all up, but it was just a script. Up here on the left, we basically have our system utilization and percentage of idle user system, how much wait time there is, and then some run queues information on types of jobs, number of jobs on the queue, this sort of information. And these are all statistics generated also by SAR, counters that are kept by the kernel. The next block down here shows us about our file systems, the number of inode gets, there's number of directory blocks, physical reads and writes, logical reads and writes, blocks that are transferred. We can see an application coming in here and doing a lot of I/O, and associated with it is some inode transfers and things like that that had to be gotten from the system. And we can see the system go up at the same time right up here. Big spike in system overhead from this file system interrogation or something going on. And at the same time, this window right here in the center is the memory map, showing us all the jobs and labeled. Now this is a 4.0 display. The 5.0s are slightly different in terms of format. But we have UNICOS as the upper red box up here that I've got marked. We have the very first image is the UNICOS binary, and then some of the system buffering or configuration buffering space, and then some of these are like daemons and stuff, and then going on to our jobs. And we see one job that came in here that's pretty big, FL or F17N, which is probably the one associated with this heavy file system usage at the same time. If we'd been watching this interactive, we could see that. Now if you bring your cursor that's on an X window system into any one of these boxes and type P, then you got a little box that told you statistics about that process. And I've done that with 2 processes here. And it shows us like our process ID and where it is. It also has parent and the second number is child utilization in terms of times. So we have like user for the parent and any children process. NQS Daemon has some child processes that are being accumulated there. We also have information about swapping. There's no swapping going on. As you can see from the memory map, we've only got maybe two-thirds of this memory being utilized on this machine at this time. This machine was 1101 with 64 meg. So there was probably only about 30 meg being used here. We also have statistics about what's going on inside the system, number of processes that have switched, system calls, reads and writes, any forks that are going on, execs, that sort of information. So a system administrator can use this to watch what a system's doing and find out what's hogging things and what's going on. Yeah.
I didn't see where you said that 30% of the memory was being utilized.
Oh, that's in the this whole window right here is memory proportional, and if it were right in half, that'd be 50. So I just kind of, there's no number that I can think of, though you could easily write that in. But yeah, that particular statistic isn't really presented there. I just estimated that based upon the ratio that's visible in this window, because that is a ratio display. The next page I'm going to pretty much skip, but USCP and NQS do have queues where they keep jobs while they're waiting to go into the system. And some of these things have caused problems on site configurations because they put USCP and NQS spooling queues on the same device, and it was a DD29, and it could not keep up with the I/O that was going on. So they learned how to tune their system a little bit more carefully. And I'm going to get you an article describing what they went through and how they tuned it from that point. Diagnostics are all the same. You have the capability of running the same diagnostics in COS as you do in UNICOS. The offline variants are the same, SRA, VRA, all those sorts of things. The monitor is written in C rather than Fortran for those diagnostics. And you also have down CPU capability. There's a CPU command with the ability to down a CPU. And there's, with the disk command, the ability to down disks. So memory diagnostics also identical. And for disk maintenance, 5.0 supports Donut now. Donut itself is simply a file or a disk format or surface analysis troubleshooting tool. It does not provide any file system maintenance capabilities like it does in COS. With COS, it can offload the file system. In UNICOS, the file system backup and offloading of the disk is done as a separate action rather than buried into Donut. So it was kind of split apart. In UNICOS, what you're going to do now is it goes with the disk command, something like you'd stop the allocation to the device and make it a read-only device. And from there, you can then use FS offload on the XMP or FS copy on the Cray2 to get the stuff off that disk drive. Then you down the disk, and that takes it out of the system, and this would make it like non-available in COS. Now, the last thing you could do then is run Donut on that particular device and do surface analysis and FLOT and that sort of thing. There's some question as to whether this is really an operator function anymore, because there is some more intricacies in doing this depending upon how your file system is configured, because you could stripe it across the file system and there are limitations. So it may not be as easy a thing to do in UNICOS as in COS is a field engineer can basically do it without any problem. In UNICOS, I don't think you trust it to them anymore. A couple other diagnostics you have UniTap for tape diagnostics and OLNet network diagnostics. And you also had AirPT, and OLHPA is a field engineer tool to look at hardware reports and give you module locations, that sort of thing. Publications, USCP protocol is both documented in the 42 manual, both SCP and USCP. The 43 manual, operational procedures, gives you your Dead Start parameter files, station debug commands, variety of things of that nature. The closest thing to it is the 2018, which is the administrator guide, and on the Cray 2, the 2019's administrator guide. So that gives you the conceptual comparison between the two systems. The 44 manual has all the administrator commands in it. That would be the 2022 manual in UNICOS. COS tables is the SM45. There is a 2014 manual, which is the file formats, but training has a tool. It's basically the same tool as on COS, ported. In fact, you need COS to generate it right now. But we generate a tables manual just like in COS. So we can generate something exactly like the 45. But it's an internal training product. And that could probably be ordered from distribution or something like that. So, but it presently requires COS in order to do it. The iOS manuals are the same. It's the same iOS between COS and UNICOS. The only difference being whether you've got operator workstation and future iOS architectures. Operator's guide, the only thing they did with the UNICOS operator's guide is tear out all the station commands. So now all it describes is all the kernel commands and file maintenance utilities of the partition, the iOS disk pack on the expander chassis. In 5.0, there is going to be an internals description manual. I don't really have the number with me on offhand. Performance utilities, there's a UNICOS counterpart to that. And I think there are several people interested in that, so let me know. And it's what I've got still 4.0. It doesn't include procstat and proc report, some of the 5.0 I.O. information. Multitasking is the exact same workbook, or exact same manual. Now there have been some benchmarks done internally, and there was a 3.0 COS 116 comparison, and there was a 4.0 116 comparison. There's not been a 5.0 comparison yet. I expect to see it this summer, late fall timeframe. But with UNICOS 4.0.4 and COS 116 bug fix 1, and they were using 6 DD49s on a 416, 218. It was basically what's called the ETH benchmark, several runs of 31 jobs, a total of 321 jobs apparently. And there's a company private document that describes this benchmark. Your analysts can get it and take a look at it. But UNICOS came out 2.6% faster. It finished first. And it gives the times that the job runs came out at and stuff like that. And the speed up, because prior to 4.0, UNICOS was slower. The speed up was due to the I.O. libraries being in Cal, whereas in 3.0 they were written in C. So anything you heard about earlier releases in the I.O. area, when we ported those Cal libraries, we got performance out of it as well. And that's mostly, I think, in the formatted I.O. area, doing formatted I.O., where the slowdown was really improved. Now, there was a problem with CFT77 segmented. We did it with a segmented 77 version, and UNICOS was slower. In fact, it says 5.8% slower than COS using CFT77 segmented. And this was due to segmentation I.O. overhead. And I mentioned this when I talked earlier about SegLoader, that it's more costly in UNICOS, more intensive. But with 5.0, they said that they'd run about 10% faster, and I don't know how that'll show up in this benchmark. But it looks like it should bring them pretty close to even again. Also, a thing to note was that there was more memory swapping occurring in these two systems. There were 30 swaps in UNICOS and 1 roll in COS. Now keep in mind there's less overhead in a swap because it's not saving enough to recover the job as it is in COS. And with CFT77, it went up to 320 swaps to 6 rolls in COS. And the recommendation that they were talking about here would be to configure the swap device on the SSD and get some of these things. None of these benchmarks did any of this utilization of the SSD for putting binaries and things on it, or using LD cache on it as well. Again, your analyst can get a report on that benchmark. The next section is a short one. Talks about how to connect to the crays. I think you've already been exposed to it now. There's a very initial project that connected the Cray 2 to a VAX when we first implemented UNICOS, and it was called Simple Effective Protocol. You'll still see it documented. These are commands like from and to, from VAX to VAX, from to to. This is only a Cray 2 to VAX link presently supported, and I don't think it'll go anywhere beyond that. But it was just what was used to initially connect to the Cray. The most common protocol out there is TCP/IP. These are commands like telnet and FTP, RCP. I use telnet and RCP most often. The remote shell is also a very handy tool, and I'll show you some things there. USCP is the station call processor. This is basically a batch job interface that connects to NQS on the UNICOS side, and everything is done through the batch environment. It does support interactive station, but I'd never recommend using it for that. Last I used it, the VI editor was still not correct for the interactive station, whereas ED would work correctly. And we'll take a look at a little bit of that. Superlink is supported with UNICOS 5.0, and that's basically transparent to the user unless you see MVS JCL in your Unix file path names. So that's what it looks like to the user. And then the file system brings it all in. NQS and RQS is a interface into the system. It uses TCP protocol to connect, but it's a whole different command interface. And this is the command qsub. And you can do a qsub -q, and if the administrator sets it up that way, YMP. That's not the way it's configured here right now. But we had, for example, a Cray 2 queue, this sort of thing. If you do a qstat or just a qstat by default, it'll show you all your queues. And typically the machine name will appear in some of the queues and show you where it's going and stuff. So it's a true network queuing system that jobs submitted could be routed to whatever machine's appropriate for that job, independent of what the user may want sometimes. The other method of connection is the network file system, and the network file system is a Unix feature, really. It basically allows front-end Unix environments to appear to be mounted on your mainframe. And you do an LS and everything's there and stuff. When you open the file system switch, same way with Superlink, detects that it's a front-end data set and then goes through the process of bringing that data set in. And the last one is CFS. Common File System is not really a supported connection to UNICOS, but we can provide you with the drivers to interface it. Most of the code comes from Los Alamos. The only advantage of CFS is for a mass storage archiving system across a number of mainframes. And this is why Livermore uses it, so that they have one big pool of all their files, and it's shared among all their different crays. Pittsburgh, University of Pittsburgh is also using it as just an archiving system to make sure that everything's backed up and stuff. Now there are several ways of getting into the Cray. It would depend upon your site. We've got 3 machines here. We've got a Cray 1 or XMP running native UNICOS. We've got a Ghost machine that's running both COS and UNICOS. And we've got a Cray 2 line here. And down here we're sitting in training. And we have 2 ways out of the system. One way is with TCP and one way is with the station. You can invoke the station if you wanted to look at it, and it's a Unix station that's running on our front end, but the CS command invokes the station. You can do a CS-C 218. And it should show you what NQS jobs are running on the system. Things like that. You can also then do your submit job. And this will send it off to NQS on that machine. Now the path out of this is when we use the station has a driver that goes directly onto the NSC hyperchannel. And we have hyperchannel adapter boxes in our computer room here, and then a trunk link to the computer room over there, all with NSC hardware. And then from there, we're directly onto an NSC box into whatever machine we want. Now if we do a telnet command, the telnet command is with TCP, and there's no actual drivers for NSC hardware for that interface. It uses Ethernet. And the way Ethernet works is we go out to what would really be called a gateway that's going to transfer it onto the hyperchannel network. And there's software there that can put it onto the network. And there's a variety of gateways that are usually that appear when you're actually doing your TCP command and stuff. Now this has its advantages over the old ways, because this link in here may be over lines or something, and if that one breaks, maybe you still got the other link. So sometimes I can get to the machine, I can't get through it this way, I can get to it this way. You can also talk to different machines, and it's really knowing the names of all your systems. And on TCP, they typically begin with an SN, and with the station, they're typically just the number. So you can get to the COS machine with a 228, that sort of thing. And it's kind of tough to remember all the machine numbers that we can get to around here sometimes. Anybody that needs to run a job on COS, we can set you up, that sort of thing. Now, in the GOS environment, there is the capability of FEI connections, but it can only talk to one or the other side of the machine. It can't talk to both at the same time. So if your site does have FEI connections, you're going to have to consider what to do there. And if you have FEI and no NSC box at all. With 5.0, there is a USCP ops command. And the USCP ops command would allow you to disconnect it from one and, talk to the other one. So you'd use the Chan command in COS to shut it off, and then you can use the USCP ops command in UNICOS to turn it on. But you can't have them both running at the same time. It's one or the other. And that is a problem for some sites. Now in a Unix environment, when you first log in, this is the way we'd get into the machine here. You no longer need a C in front of the training. So you should have been able to get this far this morning or this afternoon already now. Anyone that hasn't? Anybody? From training then, I first of all point out that there's a dot profile that's executed every time you log in. And I've set up some unique things in my dot profile just to demonstrate something. There's something called a shell function. And the advantage of a shell function is that when you exit from the shell function, you're left in the directory that you changed to. If you wrote a shell script to do this, you'd always end up in the directory you started from. And that's why I have these shell functions, so that I can change to various locations in my home directory and stuff. And then I also have a shorthand function here, just to one keystroke and I can see what's in the directory that I'm in. But I had to put these together so that I could change to that directory and stay in that directory when I'm done executing the command. With a shell script, it would not do that. It's not inherited to the child process.
So you type CT.
Right. I type in CT and it jumps off to a directory that is my temporary directory. And then I save keystrokes from no matter where I am in the system. That's why I do it. I like to save keystrokes.
Oh, I see. That's an L.
And just doing this for demonstration purposes for people that may not be familiar with Unix yet. This is the Bourne Shell. People use the Bourne Shell mostly for batch and script type languages, and then the C shell is more for an interactive type usage because of the history mechanism. But the other advantage of the C shell is that you can rewrite the thing in the C language and get optimization out of it, stuff like that. So in actual migration projects, the COS JCL will map most closely to the Bourne Shell because they're both batch-oriented languages. And you will see